Yeah, so I'm Tim van Dam. Thank you for having me. I'm really excited. I also watched a couple of the episodes, and I'm really happy that I can also contribute a bit to this community. A little bit about myself. I'm Tim from the Netherlands. I'm now sitting in Utrecht. It's getting dark already, but this is our headquarters, and this is where we are based. I am part of the organization, and I founded Smart Parks, which is an organization to protect wildlife with passion and technology. That is a bit about the background, and that is from which organization I've initiated the OpenCollar Initiative, which is where this talk is about, and not about Smart Parks. So a little small introduction. I think is good to show people that where we are coming from. So a couple of years ago, I think it's about 6 or 7 years ago, we started with the introduction of Internet of Things technology to remote areas, especially to Tanzania, to protect rhinos. And from there, we got to understand like how are these conservationists, how these protective measures being taken to these remote areas, and we found out how they were tracking rhinos, for example. So this is where the journey started for us, and we started with deploying LoRaWAN technology in Africa, and found out that this was not done before. And at some point, we got this working with rhinos, but then we reached out to existing collar manufacturers to also track other animals, and essentially it was not there yet. The technology was not there yet, so we had to do something to progress this, and therefore essentially we started OpenCollar because we wanted to do it in a different way. So a little bit about the presentation. It's a lot, so I will run through it quickly as well. Why the OpenCollar Initiative? What is the OpenCollar Initiative? A little bit about the evolution of it. Then how to use OpenCollar devices, a systems view. So how does it fit into a system technology-wise? A small demonstration. I think it's good to see that this stuff is working and how to interact with it. And then 2 behind-the-scenes scenarios of the actual application of this technology. One about drop-off failures, which also shows like the failures of developing this stuff, and a really cool new use case, which we're currently doing together with Columbia University, which is called CATS with govit. Some lessons learned, how people can help, where to go next, and some resources. So why OpenCollar? Again, I told you a bit about our background story, and we were looking for ways to integrate this new technology into these tracking devices. And at the same time, doing research, we found out that a lot of existing collars are also failing. And this was quite a high number also popping up from research. And we didn't understand that, of course, because we were new. So we tried to find out, and so there are a couple of reasons, of course, but it also shows that it's a really hard job. So we wanted to contribute in a way that also contributes to getting this number better, so making more successful deployments. We wanted to do it in a bit different way than maybe I've done before. So we want to do it in an open way, so collecting funds to do this important work. We really wanted to give this stuff back. So not only the end products, so the collars and the services, but also the schematics, the firmware, the hardware, the lessons learned. So this is why it's called the OpenCollar Initiative, and we really want to invite others also to join this cause and also to use the stuff. So this is the background story. What is inside an OpenCollar? So an OpenCollar, in our opinion, is it's about wildlife trackers. So usually it's about a collar. Of course, on a Rhino, it's a horn implant. It's not a collar, but we also consider that a open collar. There's a tracking device. There's a battery. There's collar material and mechanics. And inside that active trackers, there's a lot of technology. So in this case, we are working a lot with LoRaWAN, but also with Bluetooth, satellite navigation, but also satellite, IoT satellites, all kinds of sensors like accelerometers and acoustic sensors. So those are the main components in an OpenCollar, and that have to be developed into a package which functions and goes into the field for sometimes multiple years. A little bit about our evolution. So we started already with smart parks back in 2018 and before, and we really started at looking at a Rhino tracker because this was the first thing that drove us to do this. But as you can see here, over the past years, we have developed a crazy amount of sensors. And from 2019, we started the OpenCollar Initiative. So from that point, we started to put everything into this repository. Before, we were working with different parties. We were new. And most of that stuff was more closed source. So we accumulated all that knowledge about how to develop this and what works and what doesn't work, and put that into the new OpenCollar tracker. So you can see all kinds of Rhino trackers, ear tags, but also bigger elephant trackers, but also ranger trackers and vehicle trackers, which is you may not expect that to be in OpenCollar, but this is also very important in park management, wildlife protection, that you protect your rangers. So this is also part of the repository, which you can see here, and we're all 2021, which have all the really cool and fancy new stuff. The Rhino tracker evolved in a couple of iterations where we're adding features, making it last longer, generating more information to protect, and adding applications, even looking at other implant versions. Same for Lion and but also for bigger animals like Wisent. We developed specific trackers, and this also evolved pretty well. And of course, one of the biggest trackers is the elephant tracker, which is currently evolving into a full set of sensor-based platform, let's say. And we are planning to add more satellite connectivity, where we are trying to get more funding to get the last part of the development done. A little bit about how to use OpenCollar. This is a system view from, let's say, the device, which is the OpenCollar tracker. May it be a collar or a Rhino tracker or a ranger tracker. It is connected with your smartphone app over Bluetooth. You can configure it. Then it's the tracker is sending information, may it be a location or something else, over the network. In most of our cases, it's a LoRaWAN network, sending it to an integration platform. You can see here that we are mainly using open source tools. So this is not part of OpenCollar, but this is more how we work and how we like to work and how you can interact with it. So in this case, we're using Node-RED, the open source integration tool. Then you can send it, of course, to all kinds of storage facilities and databases. So mainly also open source, so Postgres or Influx. And of course, you want to visualize the data. We are mainly focused with OpenCollar on wildlife protection. It's getting more into the scene where we facilitate more and more research kind of questions as well. But for example, sending it to Earth Ranger, which is like the most used tool in terms of real-time data in wildlife protection, in the areas where Smart Parks works at least. But also, for example, if you want to see very fancy dashboarding, you can send it to Grafana, which is also an open source, really nice data crunching tool. And I will show a demonstration of this with an actual OpenCollar, so you have a better view on what it does. I've recorded the screens, but just to make sure it's more reliable and more convenient for you to watch. But essentially, what I'm going to do is I'm going to connect this tracker with a Bluetooth app and then go through the whole flow that I just showed. So, and I will give a voiceover. So this is the smartphone app we are now creating. It's already pretty far. And I think it's also a new way to interact with these very, very advanced devices. So imagine you are in the field, you are tagging a lion. You want to check if the sensor is working. You want to check the last functions. And this is the app you pop up with your telephone or your smartphone and you connect to the sensor over Bluetooth. And this is what you see. It's scanning. It can see all the devices which are nearby. So you click on the device you want to connect to. In this case, it's a cat tracker. You see all kinds of information about the tracker. You can see what is its last known GPS position. So you can check, is the GPS working? Okay. And then you can, of course, go into these really advanced configurations, which I think is really important because these things get so advanced. Yeah, doing this over command line becomes more like something you really need to be able to do. And a lot of people don't know how to do it, or they don't have a laptop with them in the field. Can be very stressful situations. So using an app may be more comfortable and also less error prone. So I think this is also really important. That was just a few about setting the GPS settings, so intervals and timeouts. And this is more like an interval configuration for how often the data is being sent to the network, may it be satellite, LoRaWAN, or Bluetooth, or a combination of that. There you could see contact tracing, which is scanning for Bluetooth and Wi-Fi devices. And here you are trying to get the logs of the device. So of course it's sending it, but if you get close, you can also pull down the logs of the device. It will store it on your phone. So now I'm going to send a status message over LoRa. So I'm going to connect to the next step, which is the LoRa network. It's connected to the Things network, which is a public LoRaWAN community-based network, which everybody knows in this space. And actually, I'm waiting to see the message coming in. So in a couple, here you can see the message coming in. So it's a fresh status message from the device, and it's decoded. And you can see the accelerometer values, battery values, all values that we just sent from the tracker. The Things network sends it to Node-RED via MQTT feed, and here we can see that exact same message coming in, fully decoded, and we can decide here how to process it. And here in this flow, which looks very complicated, but it's actually not, it just clearly flows from the Things network. The data flows to, in this case, an influx database, which we're going to use for Grafana, and it flows to the Earth Ranger platform where you can live see the locations coming in. Here you can see the same data, which we just received. So you can see that only one single message from such a device already creates a ton of data. And these tools just make it really easy to process it and to configure it any way you like. So this is going to Earth Ranger. You can actually see the tracker here. This is in Utrecht. I'm sitting here. It's not very accurate because it's here in the window. It's so that's why you see this big spread. And this is the Grafana platform. So if you want to see more data, because these devices generate way more things than only a GPS position, as you can see here, the GPS, of course, but it also shows, for example, the battery. And you can really easily analyze your data. So this is only showing the last 6 hours. And this is, for example, the Bluetooth scanning. So it shows like which other collars did it also see in its vicinity and what was the signal strength. So it says something about how close other collars, aka other animals, have come to the one you're tracking. Accelerometer values, here's all kinds of details about the GPS fix. So how accurate it is, how long it took, how much satellite is used. So this is, here I'm checking it for the last 24 hours and it's updating the data. So here it's pulling the database. So just to give you an impression about how, on one hand, easy it is to analyze and look at all this data, and on the other hand, you can see how far this has gone, or how much data one single color is generating. And this is clearly showing the potential of OpenCollar and how far we got. And of course the app, which I think will be a major improvement. Behind the scenes of OpenCollar development, I've picked two use cases. One is about the development of a drop-off mechanism for the European bison, the wisent. We have developed a tracker for tracking wisent in the dunes on the Dutch coast. And one of the requirements was to add a drop-off mechanism. Well, we've never done that, so we tried to analyze how to do it. And we came up with some kind of mechanical solution. And we tested it, but after 10 days, we found out that it dropped. Or actually, the color was found by one of the park management people. So, of course, now the hard stuff works. So you did all this effort, and then after a couple of months developing, you put it on, and after 10 days, it's already on the ground. So what happened? Of course, we have all this data. So we first needed to find the scenario, like what happened. So we looked into the data, and here the cool thing is that we could clearly see that at the exact moment it dropped off, because this is accelerometer values. And you can see that at some point the accelerometer was super stable, meaning it's on the ground doing nothing. So this helped us to find the exact time spot where it dropped off. And from that we could find the location where it happened, because we also got location updates. We immediately went to the field to try and simulate what happened. So this was the result, which is, I think, pretty funny. So I think this really shows how we are operating. You try to invent something and you think about a mechanical solution, but then something odd happens, and you need to go into the field and see what happens and simulate it. So here, I just took out my camera and just went into the scenario, and we found exactly what happened. So the collar got stuck behind the bush, and something broke. So we knew we had to focus on something in the design. So this was actually what happened. We tested it in the lab, but something else happened. Some other weak point came up. So now we know where to work on. And this is how we work. And this is also part of OpenCollar. So it's not only about firmware and about nice PCBs, but it's a lot about mechanical design and testing, which is fun, but really hard part. Another cool use case to show what OpenCollar is doing is cats with COVID. We got asked by Columbia University to work on a contact tracing network for studying disease transmission amongst cat and feral cats, but also raccoons in the city of New York. This doesn't sound like wildlife protection, and that's correct, but we do think that going through these really advanced questions, like how would you do this technically, you see so many similarities with wildlife protection that working on this contributes on a lot of levels. So we contribute to doing this important research, developing this, and these developments go directly into the firmware, the hardware, the mechanics we're using to protect wildlife in Africa or in India or in the Netherlands or in the States. So very interesting question, and this is part of what we are now, we've now developed with the new edge trackers. So they are able to to scan for other devices, which essentially allows you to do contact tracing because the govit app does essentially the same. We also had to make another step in our approach to make them really, really small. And we needed to essentially separate the tracker from the battery, because in this case on a collar, the battery is usually the counterweight, so you can use the top part to do the other stuff. So here we really designed a really small PCB that can be on the top, and you can just decide what kind of counterweight or battery size you want to use. And this allowed us to make a really small cat tracker. Here you can actually see in Earth Ranger the cats, and a video from a caretaker that feeds some of these cats, which allowed us to also do close encounters and update the firmware while the trackers were on. So this is also really cool with the new Bluetooth app, where you can update firmware while the tracker is already on. The collars are still pretty big, but here, the goal is of course to gather a lot of data. But they don't seem to bother too much. So yeah, we're really happy with these results. Laura Dudley-Plimpton is the researcher doing this. And yeah, we're still in the middle of the process. We will get a lot of collars back because some of them broke, of course, and we will analyze like what happened. But some of them are still working and showing a lot of good data. Also here you can see that using these dashboards will really help researchers to analyze what's happening also in real time. And of course you can pull this data into your favorite programs where you can do more data crunching. Some lessons learned from in general. I think a lot of text here, but I think I will just run them through. So developing OpenCollar trackers, we found out that every animal, environment, and application may require different mechanical, hardware, software configuration setups, meaning you almost always end up with a lot of different components, and that's not what you want, because it's very hard to maintain. It's very hard to produce. It's very expensive. So every time you're trying to push that back into like a generic thing. And I think now with the Edge version, we are pretty far with that in terms of we have minimized the amount of different PCBs and firmwares. But still mechanically, the animal and the environment will detect what kind of material you're going to use. So this is something which is very hard, and I think it's really interesting to share a lot of knowledge around that in an open way. I think that's also what's happening on WildLabs, for example. Going beyond a tracker lifetime of about 1 year requires extreme engineering on all components. I think what we have also seen entering this area is that in the beginning we thought like, just stick an Arduino on an animal and it will work. But we found out that this doesn't work, and I think a lot of people find out the hard way. If you really want to go beyond 1 year, then battery consumption, but also the type of components you're using and the materials becomes really important, and you only find out after a year. So tricky. Development of field-proven trackers require many iterations. I think that's also well known, but I think this makes it really hard. So you have to continuously test every little change you do and then put it in the field. But if you put it, for example, on a lion and the lion walks away, you cannot get that collar back really soon, So testing a new feature sometimes is really hard. So that's one of the disadvantages of developing something like this. I think also because of all these different components, it requires a huge diverse set of knowledge and skills. So I think the best way to do it is in an open community way, because somebody may be really specialized in writing super low power capable firmware, and another person may be really capable in designing the best, collar material, or the way it's stitched, or the way it's connected. And you need all those super good skills to come up with the best solution. Very important, the involvement of users. So you can come up with a lot of great ideas, but if you don't involve the FAS, the rangers, the field operators, the researchers, and the park managers, you will fail, because essentially you will find out too late that you have developed something completely wrong. And I think another point, a lesson, is that collaboration with other development organizations and persons is very hard. There are a couple of people trying to build collars and tracking devices. Some are more organizational, some are more private persons or private researchers. And we are trying continuously, but I don't know really why, but it's super hard. And I think it's culture, trust, interest, time, money, all things involved, but it's just really hard. So everybody, I think, keeps on trying, but I just want to make it clear that it's not easy to do and not obvious to make it work. New technologies will continue to offer opportunities to innovate. That's what we've seen over and over again in the past few years, is that you found some great new cool technology, but then after a year, there's already something else popping up, which is even better and faster and enables you to do even more. So while people may say, why don't you just take what you have, optimize it, and go from there? I think you should always try to innovate, because if you also can use that new technologies, you may even end up doing it better. So it's always balancing exploration with exploitation in that sense. And a final thought is that financing OpenCollar activities has required us to adjust continuously our funding strategy. We are doing fundraising from smart parks and putting that money into OpenCollar. And this is, we, of course, if you do fundraising, you have to be creative. And luckily, we find a lot of partners that like to fund specific development stretches of OpenCollar. Sometimes they directly benefit from it because they need it. But sometimes it's more like WWF that says, okay, we really like this idea and we would like you to develop this. But you have to be creative. Of course, I want to give a big shout out to a lot of partners involved, and especially ERNAS, because ERNAS is our main development partner, which is a big group of, or a big organization of very specialized engineers that is working on a lot of this tech. I really hope that we can really build this partner landscape into an even bigger landscape, so more people contribute and more people use it. If you ask me, like, how can I help, which is of course a question we got asked a lot of times, it's very hard to answer in a way to make it really specific, but just to say that we need help on all levels. So if you are really good in software, you could really help to improve and add new features. If you're really good in making mechanical designs and enclosures, we really could help use your help on designing this and adding new features. Same goes for the new smartphone functionality. It's just in the beginning, but I think adding new features and making it even more friendlier to use, or creating different versions, would really help to make it even a better thing to use. And of course, integration with other connectivity and data solutions would also help, because now we currently have about 3 or 4 different connectivity solutions. I think it would be really cool if this becomes more open also to other technologies, which may be preferable in different areas or by different users. And of course, if you have a complete new idea, why not add it? I mean, it's open, add it to the repository, and people can join. One of the hardest things is to build good documentation. Maybe you've noticed. We have a lot of documentation, but it's not organized good enough to share it in a good manner. So we are still working on that. So if you want to support us in that would be highly appreciated. And of course, building support tools. So this can be like small battery calculators or that kind of stuff. And of course, if you know any users that would benefit OpenCollar by using OpenCollar, then of course that would be also cool and very important to funding. So if you know anybody that has funding for this, please contact us. If you are somebody that really thinks like, how can I contribute in a way that I want to add to the firmware, to the hardware, I really start building this stuff myself, and you are more or less like a beginner, I would really start with looking at WILDLABS.NET for the virtual data course, or the virtual course on building your own data logger, built by Freaklabs. I think it's really cool. It goes step by step. It's really clear how to work with these kind of microcontrollers. If you are more interested in, let's say, using the data and interacting with this kind of technology, then the Hexter campaign where we did Elephant Edge is also very interesting. And in general, Hexter.io is a great platform to learn these things. Some of our resources, we have a GitHub page. We have a Gitbook, which is not open yet, working on it, but hopefully that could be the start of a better documentation. Of course, OpenCollar.io, where you can find the links to all these resources. And we are working on a forum as well. And that's it for me. That was my presentation. So hopefully you have some nice questions for me.
That was awesome. Thanks so much for that excellent presentation, Tim. We've had some questions coming in the chat. So just before we get to them, as a reminder, please keep dropping stuff in and we'll collate it on our end and then call on you to jump in and to let us know if you have mics when you ask questions. So that was super interesting, Tim. I guess I can start us off. I was super interested in your the chart of your developments over time, and it's clear that you have been very busy developing these tools. And I noticed that at each level, it seemed like there was a pretty significant increase in terms of the production goals for them. So I was wondering if you could speak to kind of what's that process been like scaling up these models, and what are the challenges you're focused on with that?
Yeah, I think it's mainly due to the fact that once you developed your first tracker, you get it in the field, and you see that there are all kinds of new requirements that you didn't knew before. Of course, you could do very good interviews and more research in advance and grasp all these requirements before you start developing. That's a way to do it. But I think, we went in it quite iterative, and so we learn with every new tracker. We learn a lot, and we find out new features, or we find out that some features are completely, well, not completely useless, but yes, less useful. So it's more iterative process, and I think that's the best answer.
Cool. Would you mind just stopping your screen share so that we can see your face in the recording?
Sure.
Awesome, thank you. Okay, moving on to participant questions. Rob, do you want to jump in first? I think you had 2 questions.
I'm coming.
Oh, there.
I'm coming. Yeah, so awesome, really great insight. I think there's a lot of people who don't, until they either put collars on animals themselves or develop collars, that don't get just how tough some of this stuff can be. I think you've done an amazing job. You said in your presentation that the cat collar was quite big, but it actually looked reasonably small to me. I just wondered, how much does it weigh? Yeah, I mean, that's not a gigantic collar. What's the weight roughly?
This one is 125 grams, and yeah, it's due to the battery, of course, and the battery is in epoxy, so that's giving the weight. So yeah, it's still quite a lot for big cat. It's okay, but it's really on the limit of what you want. So if you want less, then you use a smaller battery, and you have to. It's okay, you can do that. So it's designed to do that. But if you want to have a lot of data, in this case, the researcher wants to have a lot of data within half a year, so really intensive data, then you just need this capacity also for the GPS. And but yeah, it's well,
I think that's
on the limit.
I mean, for koalas, for example, that would actually be a very small collar, and I think a lot of people who do koala stuff over here would be really interested to see how that project goes. So, and I just mentioned in the thing, I don't know whether it's of any use, but we designed drop-offs years ago for koala collars and stuff. I doubt that our system would have worked for your bison, unfortunately, but it probably could work for some of the smaller critters that might not bash the collar around too much. So happy to share any of that, or work with you guys on making something that works as a drop-off on that front, if it helps.
Yeah.
Did I have another question, Talia?
Super cool.
That's what I was talking about.
Okay, cool. Thank you very much, Tim.
Can I add in, because Rob, I was just wondering, what's the best way for people to collaborate with you, Tim? Like, because Rob's just chucked in an offer. How do you manage that process?
It's more on a personal basis. So people that reach out to me, we don't have like a official process to do this, purely because there's not a lot of people to actually do that processing. So usually I'm directly in contact with people. I think I know a lot of people developing collars, and I try to follow everybody, also like the open drop-off, and then but I think that's one of my comments, like really working together, doing a project, because all these people I know, everybody is like super busy and trying to get his head above water. The same goes for me. So how is this process? It's a peer-to-peer, and we need a lot of more help. We just need a chunk load of more people doing this stuff, and then maybe it gets more easy. But it's a peer-to-peer kind of thing, unfortunately.
Well, you're doing an awesome job, man. Yeah.
You too.
Sure, you two are connected as well. Our next participant question was from Katie Thompson, who doesn't have a mic, so I'm going to read it out for her. She was interested in how many collars OpenCollar has deployed so far, or how many individuals you've collared so far, and do you work with NGOs? And then she's talking about how cost is a really big barrier, especially in the setting she's working with elephant tracking, and whether you think the advancement in tech will kind of help cost decrease.
Yeah, big questions. I think let's slice it a bit. But the first question was, sorry.
Oh, sorry. That was just how many individuals have you collared?
Exactly. I think that's a good question, and we just counted like a week ago, and I think all together, if we only look at about animals, we've provided trackers for about, I think, 250 over the past years. So we are not collaring animals ourselves. Let's be clear. That's done by the specialists and the teams. But I think we are about 250.
Okay.
But you can clearly see that it's going up and up from here, which must be as well, because otherwise, all the hundreds and thousands of euros would have been, you have to put that into account of each individual tracker, and then there's the other answer to your question, like what money is involved. The prices of these individual trackers are, you don't even want to know how much it is per tracker in terms of costs, because you have to put all the development, all your time, all the effort in, and each tracker would be like, I don't know, thousands of euros, literally. But from the model we use, which is using OpenCollar by Smart Parks, we produce them and we finance them for the big part. So we don't add any profit margin, or we don't add the development costs. So it's purely like cost price. So what is needed to build the PCB in series, some time assembling, that kind of stuff. And then these trackers are way cheaper than existing solutions, but that is maybe not really fair. But that's how it's now. So for example, Elephant Tracker, which can last about 8 years, we sell it for less than €1,000, and a comparable collar would be like 3,000 or 4,000. So it's a huge difference, but it's not completely fair. So it's just a differently funded, I would say.
Yeah.
It's subsidized.
Yeah, makes sense. And I'm sorry if I missed this in your talk, but I was just curious, along with that, for people who purchase one of these collars, do you then also work with them with kind of the support end, or is it more like you're doing the development and then they're on their own for the use and support for that? Yeah,
so OpenCollar is more about the development, and then if you talk about Smart Parks, there we provide the collars, and there I know at this point I know each and individual animal that has a OpenCollar. So yes, it involves support, but also the support allows you to learn. And hopefully at some point I can't do it anymore, because then there are so many collars in the field that it's just flowing and you're more collecting general information. But yeah, in the end, you want to make it so user-friendly that they don't need you. That's always what you want. And I think we're getting there for the first time really with this Bluetooth app, because anybody knows how to use an app. You can explain it, and you don't have to go into command line, because that's what it was before. You need to go into a command line, or you need to have a debugging tool or whatever. And now you can, you've seen it. It looks pretty okay, and you can just, change settings. That's how you do it. And so hopefully this will help to decrease the barrier of entry for a lot of people.
Very cool. Yeah, even the app itself looked super user-friendly. Julie, I see that you have your hand up. Did you want to jump in with something here?
Yes. Hello, everybody. Hello, team. Thank you for your presentation. I have several questions, but I just want to give you some context. So I'm Julie. I'm the co-founder of Ionif. We are a French startup, and we develop and sell a T-treat balloon inflated with helium in it, and we equipped them with antenna or camera to monitor extended sites. The 8 allow us to be free of buildings and vegetation to cover big territories. And on Wildlife Conservancy, we did several deployments in Australia and in the Réunion Island to track birds of prey and very, very, very small mammals. So we are looking for this kind of technology, this kind of collars, and a powerful platform to track these animals. But the issue is always the network. So in terms of scope of the range of the collar, how does it work on very, very large sites, and how to manage the network? And do you do only live tracking or not? So I have this kind of question, but
Yeah, thank you. Yeah, I know your organization, and I think it's really cool. And in a way, if you talk about OpenCollar, OpenCollar is in this case a platform that allows to connect the animal with this collar to the user, to the cloud or to the internet. That's why it's called Internet of Things. So in this case, if you want to do a very remote connection, then you need, of course, distance. You can go to satellites. You're talking about a couple of 100 kilometers, then you need a satellite connectivity on it. Well, on small animals, this is really hard. For example, Alistair is doing that with sea turtles. They're using Argos tags. So there you're going into Internet of Things with satellite. That is also possible with OpenCollar, but then you're looking more at the elephant trackers. We are currently more focused at using low power, long range terrestrial networks, in this case, LoRaWAN, which you're talking about a distance about 15 kilometers up to 50 or more, depending on the location of your network. So if you have a balloon high in the sky, you can reach really long range, and you can essentially connect. Yeah, essentially you're in between a satellite and a terrestrial tower, right?
Yes.
So this is how it works. And live tracking, we always try to focus on wildlife protection, not so much at research. So we are more at anti-poaching. So live information is key. Well, live is not low power. So live, we mean location update from an elephant every 10 minutes. In this case, from these cats, for example, we're talking about the location update every 15 minutes as well on this tiny collar for a couple of months. So it's crazy. You cannot get it. You cannot get a less power usage in that terms. But so this is a bit of pieces of the answer to your question.
Yes, thank you.
You're welcome.
Thanks, Julie. Okay, I think Robin had a question about ordering these devices. Robin, do you want to jump in?
Hi, Tim.
Hi there.
Can you hear me?
Yeah, of course.
Hi.
Hi, man.
Hey, Tim. I'm really big fan of OpenColors, and I really can't wait to get some of them just to test them out, in our hosted stuff. And I wonder whether you were also dealing with the chip crisis, or how do you source your GPS chips? How do you do with that? And and how are our chances to get trackers, if we buy and order them?
Very, very good question. I think some people already commented on that. But it's a real hell if you want to produce anything which needs specialized chips. We are using only the highest quality components, because if you put something on an animal, again, I think you should try to do that. And if you're doing this low quantities, there's not much optimization in terms of trying to get cheaper chips. They're still expensive anyway. So we are trying to compete with big organizations that also want to use u-blox, high grade GPS chips. So we have to find them, source them, and the problem is once you have a design. So we just popped out a couple of new designs for different trackers. For example, also the cat trackers. The design is ready. You've tested it. Then you're gonna scale up to 100 or 250 or 1,000, and then some pieces become unavailable. What do? You have to redesign your whole PCB. You have to test it again. Then you're finished testing, and then that chips or the series of the chips is gone again. So you have to go another time. So now you have to turn this around in this time. So you have to first try to imagine what components you may need, get them, pay for them. So your cash flow is gone, and then you're gonna design your thing around it. So that's what we're doing, which is terrible, because a lot of people are waiting for trackers, and you continuously have to say, well, you have to wait another month or another week or another 2 weeks. But this is you're in a way competing with very big organizations building iPhones essentially, and even they have to postpone production, right? If Apple has to postpone the production of their most valuable product, I think that says enough. So I think here, it's just we have to deal with it. And the cool thing is that we're in a way super flexible, so you can always do. But yeah, the time is going to be your enemy, and your budget is going to be killed. So,
but right now we can't buy them.
Right now, currently how we work. So again, OpenCollar is making the designs and etc. And SmartParks in this case is financing some production runs. So we're now building 1,000 pieces. So we've secured 1,000 GPS chips. 1,000 of those components. So we're building 1,000 pieces, and of that, I think about 600 or 700 have been sold. So we still have capacity, so that should be available in December, January. So yeah, we hope, hopefully we'll be okay. But that's what we did. So last week we had to decide to, buy all those components in a bigger quantity than we may wanna do. So yes, in a way it's available, but it's still very scarce. So it needs to be it needs to be important projects to assign to. So I think we should also make a pool for developers and people that want to play with it. So that should always be possible.
Have you considered going down the open acoustics route of like doing group buys or anything like that?
Yeah, I'm continuously monitoring that kind of process, but it's really hard as well, because if you want to go that route, you really have to have a very slick process in terms of what you're building, and we are not building one product.
Yeah.
Also the mechanical part, so it's a bit more complicated. I think at some point we should also do something like that, but yeah. I think they've done a great job, and I think the way AudioMod is doing this is like, the example. But somehow we can't get at that level of. I think we have too many different versions yet. Still, I don't know.
Yeah, it might be worth having to chat to Alistair, because we're collaborating on some taking the AudioMod model and taking it to other open source hardwares and trying to make that process a bit smoother. So it might be worth having a chat to him if you're interested in that space.
No, I'm super interested. Like, in a way we're doing it, but then in a bit more close environment, because the most customers or users are somehow bigger organizations that order, I think there's overlap there, but I don't know. We have to investigate, definitely.
Cool.
Steph, while you're on, did you want to ask your question?
No, chat to Al first, and then I'll ask my question.
Okay. Al, do you want to jump in?
Yeah, hi, great talk. Exciting projects. I'm just looking at the infrastructure on ground, so the park itself, or multiple parks. I'm not sure how many different areas you're working in, but setting up a LoRa network across a large area, remote areas, and getting that connection from the animal to the internet of things. Is there something already set up, or did you have to build it yourselves?
Yeah, so that's where the story started. Essentially, that's the SmartParks has been doing that. So we have introduced the first LoRa network in Africa, which was Mukomazi National Park, a couple of years ago. So then the technology there was, I think the Things network just started, which is like a community-based LoRaWAN network. And so we, the past years with SmartParks, it's like half of our activity. So we're building these networks in remote areas. So we're doing about 3 to 5 projects per year. And then, setting up towers based with solar energy, putting up gateways, and then, delivering these networks. So then these sensors can connect. So that's what we do. But in general, if there's already a network, and a lot of locations there is already a network these days, you can just plug in the sensor. So if, for example, we are always delivering them on the Things network, so you just buy a gateway. It can be as cheap as, I don't know, 80 euros. You can start from there. But of course, if you are in a very remote area and you need a professional infrastructure, then it goes a bit beyond. But it is doable.
Yeah, sounds great. So yeah, it was the Things network that you've been using as that conduit.
The Things network is like if you want to know how LoRaWAN works, and if you want to use this type of technology, which is very powerful, then that's a really good place to start, because it's already there. You just buy a gateway, you connect, and you can, of course, if you want to have more advanced use cases and you want to tailor it to what you are specifically doing, then you would maybe do something else. And there's a lot of open source resources for that as well. So we are mainly using ChirpSec, for example, which is something you privately or in a cloud install, and you essentially have all those features, but then it's a bit more tailored to what you want to do. But that's all really well documented, and that part is so it connects to those sensors quite easily.
Yeah, great. Thanks.
Thanks for the questions, Al. I'm aware we're just a couple minutes over the hour, so for anyone who has to run, thanks so much for being here, and we're going to share the recording shortly, and then look forward to seeing you all next season. Tim has said we can keep him a couple minutes over, so we're going to have, I think, 2 more questions to wrap up with. Steph, do you want to ask yours?
Oh, I said you could skip me. Okay, all right. Okay. So my questions are always like about supporting collaboration, and like we hear of like, and we know of the power of the community and people collaborating together and open source projects, but they are really, really challenging to, and you kind of touched on this earlier, they're really challenging to coordinate and get to a point where they're impactful. And you're really doing this by the direct support of smart parks, right? I was just wondering if you had any advice about, there's 2 parts to my question. 1, do you have any like great lessons learned or wish list for like things that would make things easier to coordinate like an open source project? And like you seem to be just doing it through sheer force of will at the moment, but like what would make it easier to like for people to tap in and say like what skills are needed, and like, oh, we could use help in these ways, or is there anything that could be done better in that space?
Yeah, I think it's a very good question. I think it's the key of building these communities. And I think everybody is still searching for the best answers. And I think everybody's still trying. We're also trying. So we are, for example, also, we've worked with a couple of people from the open source community, and sometimes it works and sometimes it doesn't. Are there any lessons to learn? I think we just have to keep on trying, and then sometimes it works and sometimes it doesn't. And I think these kind of talks really help, because then the community grows and gets to know each other. I think it's a lot about trust. But also I think what may be very important is you need some success stories. And I think there's a lot of success stories about individual, let's say, attempts like OpenCollar on its own, or AudioMod on its own, and Aribada on its own, and WILDLABS on its own. I think it would be really cool to have like a collaborative project where we sit together and do a collaborative success where nobody is like, the single star. But it's not about being the star, but it already indicates the issue is that everybody is so damn busy already with trying to be good at what he's already doing. But yeah, just top of my head, I've spent a couple of hours thinking about this question earlier, but I don't know the answer. I think we're already trying. Everybody's doing his best. Keep on trying, and find. Yeah.
My second, sorry, Talia. My second question was like, if you had a wish list of skills or things people could help with, what would you like love for someone like Rob has just appeared like with like cracking ability at doing drop-offs? Like, what would be your according to Akiba, which is like high praise, Rob. So we'll believe him. What's top of your wish list that people could help with right now?
Yeah, I think the drop-off is a big one. I think you have open drop-off, which is like a open source approach to making this exactly. And I think this needs to be iterated many times and replicated and tested. So I think this is a really concrete example, I guess. Also, what I really would like to see, it didn't happen yet, is that we are already in the 3rd or 4th generation of our hardware and firmware. I've not seen any other person just taking it from scratch, just from GitHub, building the PCB, sourcing the components, putting the firmware on, making some, well, not even making adjustments, doing that, just reproducing. I've not seen it done before, and I think, yeah, that's the really advanced level. Yeah? But if you really want to go into depth and you really want to contribute, you have to go through that process because it's so damn complicated that it's really hard to help on a single. Can you help me on this line of code? It doesn't work that way. It's super integrated, and they're working like, I don't know, 10 people on it, different people. So that would also be like a super advanced kind of thing. And the other one would be like more specific, like indeed working on the drop-off mechanism. We've done an attempt. We've stopped it for a while. Now we're going to redo it. We're going to relook at it. We're going to make it smaller. I have the plan to really try the open drop-off mechanisms as well, because I think it looks to be solid. So yeah, another example.
Awesome.
Can I just quickly say that on that front, I'm gonna add some things to our GitHub repo, that lessons we've learned with Kaz, and another developer who actually was the first person to make it from scratch, take the files and make it, and we've made a couple of little mini changes that I think will make it even better. So yeah, I'll do that soon.
Yeah, cool. Yeah, well, I will also reach out to you. So when we're starting the new design, we may want to get some lessons learned and then do some knowledge exchange.
Yeah, for sure. More than happy to.
Cool.
We're seeing a lot of enthusiasm in the chat too for putting together a collaborative effort based on your comments, Tim. So we are going to close the recording and the session now, but we're going to stay around and chat as always if anyone wants to continue the discussion. So thank you so much, Tim, for the great presentation and answers, and thanks for everyone for being here and being enthusiastic and asking good questions. And we'll see you next time.